Ever find yourself pinned down in a game, convinced the enemy is about to outflank you, and then nothing? Like they totally forgot you were there.
Happens to the best of us. It's a peek behind the curtain of game AI. Sometimes brilliant, sometimes. Well, let's just say there's room for improvement.
And that's what we're diving into today, right? How game AI is actually made.
Exactly. And we've got a fantastic guide, Unity Artificial Intelligence Programming. It's like a masterclass in building those digital brains.
So listeners, get ready to see those enemy encounters in a whole new light. No more taking that enemy patrol route for granted.
Absolutely. And the best part is, this book starts simple. Chapter 2 jumps right into finite state machines, or FSMs, the core logic behind so much of what we see in games.
FSM sounds a bit intimidating for those new to the world of game development.
Don't worry, it's more straightforward than it sounds. Think of it like this. Imagine that classic enemy tank from the book. Instead of complex thoughts, it operates on states: patrolling, chasing, attacking. Each state has its own set of rules, and certain triggers shift it to another state.
So it's like a flowchart, but for AI behavior.
Precisely. And when you break it down like that, it makes sense. It's elegant in its simplicity, but incredibly powerful in creating believable behavior.
Okay, I'm starting to see how this works. Our tank is cruising on patrol, following its path, but then, boom, it spots the player. Instant transition to chasing mode.
Exactly. And get this, once it's close enough, another seamless transition to attacking. This whole system of states and transitions, that's the magic of FSMs.
It's all about creating that illusion of a thinking, reacting enemy without needing a supercomputer to power it.
Precisely. And you know, what's fascinating is this isn't just for games. Think traffic lights, those automated emails you get. FSMs are everywhere.
Wow, I never thought of it like that. It's like they're the hidden gears behind so much of our digital world.
Exactly. But let's bring it back to games. Imagine you're playing a stealth game, right? Understanding FSMs means you could predict those enemy patrols, exploit their programming.
So knowing how the AI thinks gives you a tactical edge.
Absolutely. And it makes those gotcha moments even more satisfying. But AI isn't just about thinking, it's about moving through the game world too. That's where Chapter 8 comes in, with navigation meshes and pathfinding.
Okay, so we've got our AI thinking thanks to FSMs, but how does it actually navigate those complex game worlds? We don't want them getting stuck on every corner.
Exactly. Can you imagine how frustrating that would be? That's where pathfinding comes in. It's all about making sure your AI can move intelligently through the game world. Think of it like, imagine the game world as a giant grid, right?
Okay, I'm picturing it.
Now, pathfinding algorithms, like the famous A algorithm, are constantly calculating the best way to get from point A to point B on that grid. They're taking into account walls, obstacles, all that good stuff.
So it's like the AI is plotting a course, making sure they can actually reach the player, which, let's be honest, is usually their main goal.
Exactly. And it's crucial for maintaining that illusion of a living, breathing world. Because if the AI is constantly getting stuck, bumping into walls.
Oh yeah, talk about a mood killer. It takes you right out of the experience.
Totally. But when pathfinding works seamlessly, you don't even notice it's there, which is kind of the point.
Speaking of things you don't want to notice too much, Chapter 3 throws a curveball in the form of randomness and probability.
Ah, yes, the spice of life.
Yeah.
And the spice of video games, for that matter.
Because, let's be real, a game that's 100% predictable would get pretty boring pretty fast. It's like playing chess against someone who makes the same moves every single time.
Precisely. Randomness keeps us engaged, keeps us guessing. It's about creating that did that just happen moment.
So you're saying at those times when I swear the game is cheating, it's all part of the plan?
Oh, cheating might be a bit harsh, but yes, developers intentionally introduce elements of randomness. Think about those times when you're this close to winning, then suddenly, bam, a swarm of enemies appears out of nowhere.
Don't even get me started. But okay, I see how it keeps things interesting. So how does this randomness actually work? Are developers just flipping coins behind the scenes?
It's a bit more sophisticated than that. The book talks about things like weighted probability, where certain outcomes are more likely than others. It's like that slot machine analogy. Those 777s are rare, but they're what keep you spinning, right?
Okay, so it's not just random chaos. It's calculated, strategic chaos.
Exactly. It's about creating the right balance. You want the game to feel challenging, but fair, surprising, but not frustrating.
And speaking of surprising, Chapter 10 blew my mind a little bit. We're talking machine learning, the future of game AI.
Now things are getting really interesting.
This is next level stuff. We've gone from basic states to AI that can actually learn and adapt as you play. No more relying on those same old predictable patterns.
Exactly. The book even talks about a specific tool in Unity for this, the ML-Agents Toolkit.
Okay, break that down for me.
It uses something called reinforcement learning. Basically, the AI learns through trial and error. It gets rewarded for good decisions, punished for bad ones. Over time, it gets better, more strategic.
So the AI is essentially training itself to become a more formidable opponent. That's both impressive and a little terrifying.
That's the beauty of it. And while this is more advanced stuff, the book does a great job of making it accessible, giving you a starting point. But even without machine learning, those core concepts we talked about earlier, FSMs, pathfinding, randomness, they're the backbone of so many games.
Right. It's like they're the essential ingredients, and then you can get fancy with the toppings depending on how complex you want the AI to be.
Speaking of complexity, have you ever noticed how some games create these incredibly realistic crowds or swarms of enemies? Chapter 5 dives deep into flocking behavior.
Oh, yeah. Like those massive battles in RPGs where it feels like there are hundreds of characters moving around independently.
It's amazing, right? And it all comes down to some surprisingly simple rules that create this emergent group behavior.
So it's not like each individual AI is programmed to move in a specific way. It's more about...
It's about setting a few basic parameters,
Yeah.
then letting the AI interact with each other. The book uses the analogy of a flock of birds. Each bird just follows a few simple rules. Stay close to your neighbors, avoid collisions, but put them all together, and you get these incredibly organic, flowing movements.
That's amazing. It's like a choreographed dance, but the dancers are writing their own steps in real time, and it's all thanks to some clever coding.
Exactly. And the best part is, these techniques can be applied to all sorts of games, from those epic battles to more subtle interactions.
So it's not just about making a crowd look realistic. It's about making it feel alive, responsive.
Exactly. And you know what else adds to that feeling of lifelike AI?
Yeah.
Those moments when it seems like the enemy knows exactly where you are, even if they shouldn't.
Oh, you mean those times when you think you're being stealthy, hiding behind cover, and then bam, they find you anyway. It's like
No.
they have a sixth sense.
Chapter 6, my friend.
Mm.
Obstacle avoidance.
Hmm.
It's like giving our AI a sixth sense.
So how do they code that? Do they give the AI X-ray vision or something?
Not quite. It's more about giving them the ability to see their surroundings in a different way. The book uses this cool analogy of a car avoiding obstacles. Imagine a driver, right? They see an obstacle, they steer around it, simple. AI does the same thing, just with code instead of eyes.
Okay, that makes sense. So it's not about knowing your exact location. It's about predicting where you might go based on the environment.
Exactly.
Yeah.
And when it's done well, it creates this really convincing illusion of intelligence. Even if it makes you want to yell cheater sometimes.
Oh, yeah, I've definitely been there. But hey, it keeps things exciting, right?
Speaking of exciting,
Yeah.
Chapter 9 takes us even deeper into the AI rabbit hole with behavior trees.
Behavior trees. Okay, now we're getting really fancy. What are those exactly?
Imagine a flowchart, but instead of just states, it maps out the AI's entire decision-making process. Different actions, conditions, all linked together to create much more complex behavior.
So it's like FSMs on steroids.
You could say that. The book is an example of a patrolling robot. It's programmed to shoot at anything that gets too close. The behavior tree breaks down that behavior into smaller tasks, conditions detecting the player, aiming, firing, all connected logically.
Okay, so it's not just about reacting to a single stimulus anymore. The AI can now consider multiple factors before making a decision.
Exactly. It's like looking at a blueprint for the AI's brain, seeing all those thought processes laid out.
That's incredible. So with behavior trees, we're talking about AI that's more dynamic, less predictable. No wonder those boss battles can be so intense.
It's all about layering these different techniques, right? From those basic FSMs to these sophisticated behavior trees. It's how developers craft truly engaging gameplay.
Okay, so let's recap. We've got the brains with FSMs and behavior trees, the senses with sensors and obstacle avoidance, the movement with pathfinding. We're basically building a virtual being here.
And this brings us to the grand finale, Chapter 11. Remember that tank battle game we talked about earlier? This is where the book pulls it all together. You actually build a complete game using all these AI techniques.
Whoa, from theory to practice.
Exactly. It walks you through using Unity's navigation system, creating that dynamic battlefield where AI tanks move around, avoid obstacles, and of course, try to take you out.
So it's like the ultimate test, putting all those AI skills to work.
It's proof that with the right tools and knowledge, anyone can understand and create those compelling AI experiences. Those moments that make us forget we're even playing a game.
And that's the magic of it all, isn't it? The way these digital worlds can come alive.
It's been a blast diving into this with you.
Absolutely. And listeners, we hope this deep dive has given you a whole new appreciation for the art and technology that goes into creating those unforgettable gaming moments.
Next time you're playing your favorite game, take a moment to appreciate the AI. Those enemy encounters, those epic battles. There's a lot more going on under the hood than you might think.
And who knows, maybe this will even inspire some of you to create your own AI world someday. Until next time, happy gaming.